Okay, one concern about the mods that I just want to go over real brief, so you don't have to watch too long of a movie. Hate to cut into your free personal time, but this is the chart that we had in the book that we first did this, and I knew it would be a problem back in the day because it is a little bit mind blowing. But I'm going to take this row, for instance, and just take a couple out of these, like 1 mod 7. Um, that equals 8 mod 7, or we could just say 8, because 8 has a remainder of 1 when divided by 7 as well, which is the same as 15 mod 7. So all these, basically what we could say is all of these numbers here, 8 mod 7, 15 mod 7, all from this row. Oh, great announcements. 22 mod 7. These all equal 1 because they all have a remainder of 1 when divided by 7. So that's what this row means. So this is where it gets weird. Hopefully you can't really hear too much in the background. Now I'm going to word it just like how the book does. 8 mod 7 is 1 because 8 is 1 more than 7. It's 1 above the nearest number divisible by 7, which is 7. 15 is 1 more than 14, so it has a remainder of 1. Because now I'm going to mess with your mind. Negative 6 mod 7. Well, of course, by the chart, you're going to be led to believe that this is also 1. Because negative 6 is 1 more than the nearest multiple of 7. And this math holds true. Just like this is 21 plus 1. Okay, so there's a remainder of 1 when 22 is divided by 7 because it's 1 more than the nearest divisible number by 7. So that's what happens with negatives, and you have to kind of think weirdly on this. Negative 13 mod 7 is also 1 because negative 13 is 1 more than the nearest number that's divisible by 7. So that's what happens with negatives, and this is a little bit strange. So we are going to just have to accept that from this one little example. Looking at these, yeah, this is crazy. 27 mod 7 is equal to 6 because 7 goes into 21 with a remainder of 6. Now we go all the way to this chart here. What's negative 15 mod 7? This is 6 more than the nearest multiple of 7. So that's why this is also 6. So again, I did that just pulling another one randomly just so you get the idea of how negative mods work. Crazy stuff, I get it. Then one more, I'm going to come up with an example of powers. Only one group, group 6, did an example of powers. So if you want to look at their notes that I posted online, go ahead. By the way, period 1, you didn't make your PowerPoint shareable, so I could not share that today. Okay, here's another one. You can't even do this on the calculator. If we did this on the calculator, we'd raise this to this power. Overflow, I think the calculator destroys, and you can't really read the number. Then you divide by 7. Then you can get, what the remainder is as a decimal and multiply that by 7, as said by all of the groups, how you get a remainder out of stuff. That's the point of this. We're trying to do something different here. So we're going to use our properties, but what we really want to try to find is 5 to what power equals 5 to what power mod 7 equals 1. And then when we find that, 1 to any power is 1, and then that's how this is going to proceed. So we're going to kind of do the product rule by busting up the exponents here. So what's 5 mod 7? 7 goes into 5 0 times with a remainder of 5, so that doesn't quite work. So we got to move on. What's 5 to the second? 25, and at some point I'm going to have to use my calculator. 5 squared is 25. 7 goes into 21 with a remainder of 4. So that's 4 when you actually do this. So I don't have 1 yet. 5 to the third is 125. My brain's shattered. I have to go to the calculator now and take 125. That's 5 to the third for those that don't know. Mental math. All right, and then you take that 0.8, and I think that's going to end up being 6. But let's see. Minus 17. I just want the decimal part. Times 7. I was right. Okay, let's go 5 to the 4th. No, let's not. That's 625. I know my times tables. How about you? Point 2, we're getting close. So subtract 89. By the way, 89 is the quotient of the division statement. And then this would get me the remainder. When I lop off the 89, and then I multiply that point 2 blah, blah, by 7. I think I'm going to get 2. Darn. What I want is 1. So I have to keep going. Big whippity doodah. Those crying at home. I have to do all this. All right, 5 caret 5. You're pressing some stinking buttons on a calculator. What's the big deal? Did I say good afternoon, by the way? Minus 446, and then multiply that by 7. I know this isn't 1. This is going to be the 3. We're going to get there, okay? And it's going to happen, and then we'll see what happens mathematically, how we break down the exponent. 5 to the 6th. Oh, I hate math. All right, 5 caret 6. Divided by 7. Okay, that's the quotient. This is the remainder. I know that's going to be 1. Oh, I better do it. How'd you get 1? All right, subtract 2232, enter, and then multiply that part by 7. Told you, you never trust me. 1. So, 5 to the 6 mod 7 equals 1. So this is what we're going to do. We're going to make this 5 to the 6th raised to a power times 5 with some leftover powers to actually evaluate this mod faster, because 5 to the 6 to whatever power is, we're going to 5 to the 6 mod 7 that get 1 and then raise 1 to that power, and we're going to get 1 out of this. So what I'm doing is reducing the exponent, so then it's something I can work with and evaluate. Now there's this basic mathematical reasons why I do this. What I want is the nearest multiple of 6 that makes up this power. And I should have known it's 300. So here, it's 50 that I'm going to put here. And I'm doing this to use my exponent rules. 6 times 50 is 300. So I've taken 300 out of this power here. And what am I left with? 2. That's it, folks. All right. Now I get the mod 7, this product individually. Now 5 to the 6 doesn't equal 1, but what we're using is that rule of product and power rule together. What I could do is 5 to the 6 mod 7 and get 1, and then raise that to the 50th power. All right, so that's how this all happened. And then this ends up being 302nd power, which was the question. So I'm only using exponent rules from Algebra 2 or Math 2 if you were lucky enough to take that class. So 1 to the 50th is 1, and then all I have to worry about is 5 squared mod 7, which we actually already evaluated over here, but we also know is 4 mod 7. So the answer to this is 4, or 4 mod 7. And you did this just through the glory and power of exponents. We also had it right here. So 4 or 4 mod 7, you'll be prepared for either of those answers. It's the same. Okay? All right. Done. I got to go.